Law of conservation of mass. Now, law of conservation of mass, it comes under, when you go to class 11, you will be studying, there are 5 laws of chemical combination. This is law of conservation of mass. Another 4 laws are law of definite proportion, law of multiple proportion, law of reciprocal proportion, and Gay-Lussac's law. Of course, Gay-Lussac's law you will be studying in class 10 also. Okay, fine. So, law of conservation of mass, who gave it? It was given by Antony Lavoisier. It was given by Antony Lavoisier. Now, this law is in accordance with the law of conservation of energy, which you must be knowing. Law of conservation of energy states us that energy can neither be created nor it can be destroyed. Total energy always remains constant. Only it can be converted from one form to another form. Again, I repeat, the law of conservation of energy states that energy can neither be created nor it can be destroyed. Only it can be converted from one form to another form. That is, total energy remains constant. So here also the same thing. Got it? As I said, it is in accordance with the law of conservation of energy. Now, what the law of conservation of mass states us? Please listen carefully. In any physical or chemical change, in any physical or chemical reaction, the total mass of the reactants before the reaction is equal to the total mass of the product at the end of the reaction. Alright, again I repeat, in any physical or chemical reaction, the total mass of the reactants before the reaction is equal to the total mass of the product at the end of the reaction. That means what I can say, that is total mass of reactants before reaction is equal to total mass of product at the end of the reaction. Now you will prove it this one. This particular thing will prove it. A very simple experiment I will tell you. What you do is that you just take conical flask, you take it and you put some ice inside the conical flask. Okay. Now you just put a cork there in the conical flask and put some Vaseline around it so that no energy can get in or it can be lost into the surroundings. Got it? What I said, you take a conical flask, you put some ice, put a cork, a tightly fit cork, and put some Vaseline or wax around it so that no energy can be lost or gained from the surroundings. We can say that. Okay. Now you weigh it. You just weigh that particular one. That flask with ice, you weigh it. You take the weight. Got it? You just calculate the weight, you take it. Let us say the weight you get is 500 gram. Let's see. Now you wait for some time. Just you put the flask outside. Nothing. You don't have to do anything at all. Just you put the flask outside. After some time you see that the ice melts to form water. Got it? It's a physical change. Ice was the reactant. You got the product as water. It's a physical change. So now the water which you got it, again you reweigh it. Again you reweigh. What you will see? The weight now also comes to be as what? How much? Same 500 gram. So what does it mean? The total weight of the reaction before the reaction is equal to total weight of the product at the end of the reaction. So what I said you, remember it? In any physical or chemical reaction, now this is a physical reaction I am giving you. Now let me give an example of a chemical reaction. Let me give an example of a chemical reaction. Now this particular one experiment which I am going to do, it is known as Landolt experiment. Landolt experiment, this is known as. And the tube which I am going to take it to do this particular experiment, apparatus I am going to take it, that is called as a Landolt's tube, or it is also known as H tube, because the shape of the tube is in the form of H. Now you can see it. It is in the form of H. You can see it's an H. You can see that. Clear? So this Landolt's tube or the H tube I have taken. Now here an opening is there. Of course an opening is there in both of it. We have an opening. Through this opening you will add here, what is that? I am going to add it here, NaCl. Sodium chloride solution I am going to add it in this particular limb. Now in this limb what I am going to do it as, I am going to add it silver nitrate, AgNO3 solution. Now you close the mouth of this particular, what you can say, limb. You close it. Just you put the cap, the cork, you put it. And you cover it with what you can say, wax, or the air hole which is there, you cover it with wax or Vaseline, so as to ensure that neither energy is lost into the surroundings nor any energy is gained from the surroundings. Got it? Clear? I think you are following what I am speaking to you. So that is, we have taken a Landauer's tube or an H tube, and in this limb I have taken sodium chloride, in this limb and silver nitrate. Don't disturb it. Without disturbing it, what you do is that you take this particular apparatus and you weigh it. Without disturbing it, you weigh this particular apparatus. Let us say this weight comes to be as 250 gram. That is reactant, the weight of the reactant along with the tube, along with the H tube, the glass tube. You got it as 250 gram, let us say. You got the weight before the reaction. Now what you do is that you turn the tube upside down. Nothing to do. Just to turn it upside down. So when you turn it upside down, what will happen? NaCl will react with AgNO3. It is going to form what? A white PPT AgCl. It is going to form a white PPT AgCl. Say I am not having space, I am writing it here. Plus NaNO3, it is going to form a white PPT. This is a white PPT. This is AgCl and NaNO3. So as soon as you turn it upside down, you will see a white PPT is formed. Just to wait for some time for the reaction to get completed. Just to wait for some time. Once the reaction has got completed, got it? That is AgCl plus NaNO3. I think you can see it very clearly. That is AgCl and NaNO3. It is being formed. Once the reaction has got completed, what you do is that again you re-weigh the tube. Again you re-weigh it. Got it? After the reaction has got completed, that means you are going to take the weight of the product. How much it is? Same thing, 250 gram. Same thing. So weight of the reactant was 250. Now the weight of the product is also 250 gram. The weight of the product. Let me write it here. I don't have the space. That is weight of the product. How much it comes to be as? 250 gram. The weight of the product. Alright, what is the product? AgCl and NaNO3. How do we know the product is formed? A white PPT is formed. So what does it prove? These two reactions. It proves that during any physical or chemical change, that is the total weight of the reactant is equal to that of the product. Clear? So in this way, many more experiments we can give it. For example, if you burn magnesium in air, alright, you will get magnesium oxide. Now it seems to you that it is losing weight. No. Magnesium combines with oxygen. Alright, Mg plus O2. I will show you this one theoretically. This particular one I will show you theoretically. We will calculate it and I will show you. Now see an example. What I said, magnesium when it burns in air, Mg plus O2 on heating, what it gives? It gives 2 MgO. Now 2 Mg plus O2, let me balance it, 2 Mg plus O2. This is magnesium ribbon. When you burn in air, you get it, magnesium oxide, which is a white powder. Same thing, you do it in a closed container. You heat it in a closed container, this one. Alright, yeah. Then what I am going to get it? This is the weight of the reactant and this is the weight of the product. I have to show it that this total weight is equal to this total weight. So what is the atomic weight of magnesium? Atomic weight of magnesium is, that is nothing but 24 gram. So how much you got it is 48 gram. I will tell you about the atomic weight in the next. Now here oxygen, here 2 oxygen atom is there, you can see. So 2 into 16, how much you got it is 32 gram, 2 into 16. So all together how much you got it? 48 plus 32, 2, 8 plus 2, 10, 4, 3, 7, 1, 8. How much it is? 80 gram. 80 gram is the weight of the reactant. Now let us take the weight of the product. Now magnesium is how much? 24. Oxygen is how much? 16. What I said you? 2 into 16. You see here. One oxygen atom is 16 gram. So 2 into 16. So here it is 2 into 16 because 2 oxygen atom is there. So here how much we get it? 24 plus 16. How much it is? Nothing but 40. So here 2 is there. So 2 into 40. How much I get it? Same thing, 80 gram. Alright. So here 80 gram is what? It is the weight of the product. It is the weight of the product. See, 80 gram. See carefully. It is 80 gram. This is 48 gram. This is 32 gram. Total comes 80 gram. Here it is. Magnesium weight is 24, oxygen weight is 16. 24 plus 16 is 40, 2 into 40 it is 80 grams. So total weight of the reactant is equal to that of the product. We can say that. In this way, it seems to us initially that magnesium is losing weight, but no, that always, according to the law of conservation of mass, the total weight of the reactant is equal to that of the product in any physical or chemical reaction. Similarly, when a candle burns in air, it seems to us that it loses weight. No. Candle combines with oxygen. Candle is what? Any hydrocarbon. It combines with oxygen to form, that is carbon dioxide and water. If you want, I'll write the reaction. Hydrocarbon is CXHY plus oxygen, it gives nothing but CO2 plus water. Any hydrocarbon burns in air to give you carbon dioxide and water. So it is XCO2 and it is Y by 2 H2O, and this is nothing but X plus Y by 4. this particular one reaction is X plus Y by 4 O2. On heating will give you X CO2 and Y by 2 H2O. You will be getting it. This particular reaction you will be knowing it in details when you will go to higher classes in class 10. When you will study organic chemistry, you will come to know in details in this way. So always total weight of the reactant is equal to that of the product. We can say that. Clear? Okay, fine. So in this way, this is your law of conservation of mass. Now here some numericals is there. The numericals I will work it out in a piece of paper and I will send you the picture. You go through it, alright, and solve it accordingly. I will give you the questions also. After that, you solve it accordingly, and if any doubt is there, please ask me. Thank you very much.